I don't know why this is called a rate of change in slope, because they're the same thing. So anyways, that's weird. So basically with slope, what we're looking at is a triangle stands for change, okay? That's what it stands for in math. So we have the change in y over the change in x. It's also looked at as, you will see it as rise over run. And a way to remember that is you have to rise before you can run. Okay? So we're going to go ahead and take a look at this lesson. It doesn't go into a lot of detail. The next lesson will do the slope formula, which they usually teach first. It's a little bit easier, but for whatever reason they just decided not to, and that's fine. So we're going to look at the consumer application. So when you're looking at a table, there's a table here and it shows the cost of mailing a 1-ounce letter in different years. The first thing you have to do is identify the dependent and independent variables so you know which one's your x and which one's your y. Okay, so this is your x and this is your y. Anyways, and because of the fact that it's in a table, usually the first one's x and the first one's y, that kind of gives you a little bit of a idea on that. So, what we have to do is we are looking at these two, and then we're looking at these two, and we're looking at these two, we're looking at these two to find the rates of change, okay? And we want to find the change. So in this we have 88 to 90, and we want to find the change in y over the change in x. And when you're finding the change, you are going to subtract. Okay? So, if we're looking at the years 88 to 1990, what we're going to do is we're going to subtract And the thing that you need to make sure is that you have the change in cost first, and then you have the change in years, because that can get confusing because it's opposite of what this says x over y, and I think your natural tendency would be to just write it out in order, but it's actually the change in cost over the change in years. It flip-flops when you're finding the rate of change. So, like I said, when we're doing change, we're subtracting. So the first thing we're going to look at is the cost, and it's 25 minus 25. Okay, and then the change in years, we're going to do the second, 1990, minus the first of 1988. Okay, and that's a good introduction into the slope formula, which we're going to learn in the next lesson. Even though 25 and 25 are the same numbers, we're actually subtracting this 25 first. That's our first number, and this 25 is getting subtracted from it. You can't really see that though because they're the same number. And that equals 0 over 2, which is 0. So it's 0 cents per year. There was no change. Okay? Then we're going to look at, we're not going to do all of these, don't worry, that would take a while, and this movie would be super long. Plus, we're going to learn more about this tomorrow. So, the next thing we're going to do is we're going to do, let's do 2004 to 2008. Okay? So, 04 to 08. Since you were actually born then. And so we have the change in y, which remember is the cost, over the change in x, which is the years. Okay, so we're going to look at the cost first. And we have 42 and 37. So we're going to subtract the second cost and then the first cost. So we're going to subtract 42 minus 37. And then the same thing for years. The year you see second comes first minus the year you see first. Okay, and we get 5 over 4, and 5 over 4 transfers to 1.25 as a decimal. So 1.5 cents a year. So I'm just going to tell you that the slope formula, m equals slope. When you see the letter m, that means slope. So you're going to have m equals y2 minus y1 over x2 minus x1. And that tells you, like we just said, this was I'm sorry. Put it in the wrong spot. That tells you that this is y2 and this is y1. y1 comes first, y2 comes second. And then this is x1 and this is x2. But then when you put them into this formula, they switch places because you put y2 first and y1 second. And we'll talk about that more tomorrow, but that'll give you an idea of what's happening, and it won't be such a long lesson tomorrow like it probably is going to be today. So the next thing we're going to look at is, if it loads, there we go, finding the rate of change from a graph. That can be a little difficult. I'm gonna skip example 2 because example 3 is the same exact thing. If it tells you to find the rate of change or it tells you to find the slope, that is talking about the same exact thing. Okay, so don't get confused by that. Maybe write that down. Rate of change is the same as slope. The only thing is rate of change isn't all the times constant, and slope is constant. Okay, so rate of change, you might have to find, I'll take a picture of 2 different graphs and show you how they're different, but we won't do the problem. So what that's going to look like, this here on the left is finding the rate of change. Okay, and this line isn't straight, it's all over the place, so you're going to have to find a bunch. That's showing the change in cost about letters that we were just working on, and it's not constant. Whereas if you notice, find the slope of the line, this line here is constant. There's no like jagged, like, oh, we're going straight, and then all of a sudden it levels up, and then it goes super steep, and then it goes down. Okay, so that's the only difference from rate of change that you're gonna see. We're gonna use that same picture. I hope that didn't record the whole time and you have to watch me take a picture and stuff. Alright, let's see here. There we go. It's the same picture for example 3. So, example 3 is finding the slope of the line. What we want to do is, sometimes this line will give us 2 points like this one does here. We have a point right there, and we have a point right there. However, if it does not give you 2 specific points, you can pick any specific point, or any point you want. But the easiest way to pick these is where it falls, where the lines cross. So where the little graph lines cross, you would pick those points, okay? So if you had a line and it was just like this, and it didn't really fall, like it ran through a bunch of points, and you would pick this point here because it crosses at where those horizontal and vertical lines intersect, and we're going to pretend like this one does too. So you would pick that one. Okay, so if they don't give you any points to pick the points where the line crosses the vertical and horizontal lines perfectly. However, they do in this one. So what we're going to do is, that's what I tell children to do, just like they have, is these little triangles. Okay, so you would have these triangles here. Okay, and you would look, okay, we rose up 1, 2, 3, 4. I know they have rises 4, but y equals 4, and then we ran 1, 2. So x equals 2. And then our fraction is the change in y over the change in x, or it's y over x, so you don't have to put change. And we have 4 over 2, which goes over to 2 over 1. So that's where they got the run as 1 and the rise as 2, is because they had already simplified it. Okay? And this is the same thing. You could use the bottom half, or you could use the bottom triangle here, and you have 1, 2, 3, 4. And for your rise, and since if it's on the bottom half, we can make it negative. And then our run is 2, and since it's on the bottom side of the line, we can make that over negative 2, but they're both positive numbers, so they equal 2 over 1. Okay? So you just look at how far you rose over how far you ran, and then simplify. Okay, so on these ones, remember we have y over x. Oh, it's not writing. So we don't go anywhere, we don't rise at all because it's a straight horizontal line. So if we don't rise at all, it's 0. Over, we look at our 2 points and we see how far we ran. 1, 2, 3, 4. We ran 4 places to get from negative 1 to positive 3. 0 over 4 is 0. Okay, so if you ever have a horizontal line, the slope is 0. Vertical line, we still have y over x. So we look at what we rose to get from 1 to 3. We rose 1, 2 places. However, we didn't run at all because it's just a vertical, and you cannot divide 2 by 0, so your slope is undefined. So if you have a horizontal line, your slope is 0. If you have a vertical line, your slope is undefined. And there's a little picture here that I'll put in here that gives you all that information. I'd suggest you write these down, okay? So a positive slope, the slope is always referring to the x. Slope refers to x. So if you have an equation, it's like graph the equation of y equals 2x plus 3. The slope is referring to the x term. Okay, so if a line rises from left to right, it's positive slope. So if it falls from the left to right, it's negative. So like this one, you're going uphill. This one, you're going downhill. So you're gaining altitude or losing altitude. Horizontal line, 0 slope. Vertical line, undefined slope. Because sometimes you're just going to have like a picture of a graph and it's going to say, is it positive, negative, 0, or undefined? You're not going to have to do any work, but you just have to look and be like, oh, that has a positive slope. You don't necessarily have to put any more than that, which is easy. So, comparing slopes, it has a little thing on comparing slopes. A line's slope is a measure of its steepness. Some lines are steeper than others. As the absolute value of the slope increases, the line becomes steeper. In my world, you can tell which line is steeper, okay? Which line would you not want to ride your bike up? And it's probably always going to be the steeper one, right? Like, we're not going to try and be like superheroes here if we're comparing this line with this line, which one is going to be more difficult? This, which means that's the steeper slope. Same thing, if we compare this with this, which one's the most difficult? It's going to be able to get up? This one, so that one's steeper. Same thing with these. If we compare this one and this one, the one that's going to be the most difficult to bike or climb or whatever is going to be this one, so it's the steeper slope. So they have you compare slopes. They make you find the slopes and then find the absolute value, but you can visually see those. So sorry this lesson was a little bit longer. We are done.